Space exploration has given us incredible things. Satellites connect us across vast distances. Telescopes reveal the secrets of the universe, but there's a hidden cost: space junk. Space junk is any object in orbit around Earth that no longer serves a purpose. This debris ranges in size from tiny flecks of paint to defunct satellites. It might sound harmless, but even small pieces pose a real danger. Imagine a tiny paint chip hurtling at thousands of miles per hour. This high speed gives the chip incredible energy. If it were to collide with a working satellite, the damage could be catastrophic. The problem is only getting worse. As we launch more objects into space, the amount of debris grows. This creates a dangerous cycle, increasing the risk of collisions and generating even more junk. Where does all this space junk come from? The answer lies in our history of space exploration. Since the launch of Sputnik in 1957, we've been steadily adding to the problem. One major source is defunct satellites. These are old satellites that have reached the end of their operational life. They remain in orbit, adding to the growing cloud of debris. Another source is rocket parts. When rockets launch, they often leave behind pieces like spent boosters and fairings. These pieces can remain in orbit for years, posing collision risks. Accidental collisions also contribute to the problem. When two objects collide in space, they can create thousands of smaller fragments, each one a potential hazard. Even routine operations can create space junk. Small particles like paint chips and metal shavings can flake off rockets and satellites, adding to the debris field. Space junk comes in all shapes and sizes. It's helpful to classify this debris to understand the scope of the problem and the risks associated with different types. The largest category is derelict spacecraft. These are non-functional satellites, spent rocket stages, and other large objects. They pose a significant collision risk due to their size. Next are operational spacecraft. While these are still functional, they can shed small parts like paint flakes and insulation, which become hazardous debris. Fragmentation debris is a major concern. These are smaller pieces created by collisions between larger objects. They're harder to track but can cause significant damage. The smallest category is microdebris. This includes tiny particles like paint flecks and solid rocket motor exhaust. Though tiny, they can still damage sensitive equipment on satellites. The increasing amount of space junk poses several serious threats to our spacefaring future. Understanding these risks is crucial for taking action to address the problem. The most immediate threat is to operational satellites. Collisions with even small debris can damage or destroy these vital tools, disrupting communication, navigation, and Earth observation. Space junk also threatens human spaceflight. The International Space Station, for example, has had to maneuver several times to avoid collisions with debris. Future missions, like those to the Moon and Mars, face similar risks. The Kessler syndrome is a terrifying possibility. This theoretical scenario predicts a cascade of collisions in space, creating so much debris that space exploration becomes impossible. Finally, uncontrolled re-entry of space junk poses a risk to people and property on Earth. While most debris burns up in the atmosphere, larger pieces can survive and reach the ground. The good news is that we're not powerless against space junk. Scientists and engineers are working on innovative solutions to manage and reduce this growing threat. One approach is spacecraft design. By building satellites with features that minimize debris creation like shielding and tethers, we can slow the growth of the problem. Deorbiting systems are crucial for removing large objects from orbit. These systems can safely guide defunct satellites and rocket bodies back into Earth's atmosphere, where they burn up. Active debris removal technologies are being developed to capture and remove existing debris. These technologies include nets, harpoons, and robotic arms, all designed to grapple with space junk. International cooperation is essential. Sharing data, coordinating space traffic, and establishing international regulations will be crucial for effectively addressing the problem. The future of space exploration depends on our ability to solve the space junk problem. By investing in research, developing innovative technologies, and fostering global cooperation, we can ensure that space remains a valuable resource for generations to come.